Hi and welcome to Year 9 Maths D video for here, topics of limits of accuracy, still under the bounds of measurement. Now today we're going to deal with how to multiply and divide measurements with the bounds that you will have later. So you have two different bounds for your information. You have lower bound and upper bound. So know that in multiplying measurements you have to do multiplication, right? So when you find the lower bound, you have to multiply the lower bound. Okay, remember that. And when you try to multiply, when you want to find the upper bound, you have to multiply the upper bounds of your measurements. Okay, now let's move on to the next one. When you try to divide measurements, when you try to find the lower bound of your division, basically you have to first put your lower bound of the first quantity in your numerator, and the upper bound will be your denominator. Now, okay, for the division, you have to find the upper bound by using division of the upper bound of the first quantity divided by the second quantity of your lower bound of your second quantity will be on the denominator, right? So let's proceed to this one. Okay, just consider that you have a piece of A4 paper, so you will have 21.0 centimeter by 29.7 centimeter as your dimension of the paper, but here it is correct to the nearest millimeter, and so from that you know that 1 millimeter is 1 out of 10 centimeter, so this is 0.1 centimeter. So your error will be 0.1 divided by 2, it will be 0.05 centimeter. Okay, the question here is that what are the upper and the lower bound of the area of the piece of paper. So here, let's fill in the dimension correct to the nearest millimeter. So your upper bound will be here, this is the length, so 29.7 plus 0.05 will be 29.75 centimeter, and the upper bound of the width will be 21.05 centimeter, right? So the next one will be when you have the lower bound of the piece of paper. So here it will be the length 29.7 minus 0.05, you will get 29.65 centimeter, and for the width it will be 21.0 minus 0.05, you will get 20.95 centimeter, right? So when you try to find the area, you are basically multiplying the length and the width together. So when you multiply to find the lower bound, you have to multiply the lower bounds of your measurement or the dimension. And for the upper bound, you have to multiply the upper bounds of your measurements. So here, therefore, the lower bound of the area will be the right one, right? So 29.65 multiply 20.65, right? So just fill in the number. Okay, 20.95 times 29.65, and you will get a number that are not exact. So you will write it like this first. You have to find it. You will get the exact area, which is this one. Now, okay, now I'm going to use this one, or we are going to use the idea that we have learned last time, which is on using sensible degree of accuracy. So here, since you are using 2 decimal point as your dimension length or the width, you are going to round off this one. So you will get 61.17 centimeter. So this is the lower bound of the area, right? Now, let's move on to find the upper bound of the area. So here you are multiplying the upper bound, which is 21.05, multiply it with 29.75. So here you will get an exact area of 626.2375. This is too accurate, so you will use the more sensible units of accuracy, which is the same as your dimension, which is 2 decimal places. So your answer will be 626.24 centimeters square. Now, this one will you are using the more sensible one, but it depends on the question. Sometimes it asks you to run off your answer to three significant figure. All right. Now here, this is just the idea. When you are trying to divide the when you're trying to divide, you have to know that when you divide a number with a larger number, you will get the smaller answer. So to find the lower bound, okay, the first quantity lower bound is going to be divided by the upper bound of the second one. And to find the upper bound of division, so you are starting with upper bound of the first quantity divided by the lower bound of the second quantity. Now this one, the formula, it seems like you did not know what to use, but later in some real life example, for example like speed over here, you are going to use it. Okay, so let's begin with example number 1. So example number 1 over here, gun cycles 14.2 kilometer. So this is three significant figure. So basically this is the same. The units of accuracy will be 0.1 kilometer because here is your approximation. So your error will be 0.05 kilometer, right? And then in a time of 46 minutes, this is to the nearest minute, so 1 minute divided by 2, so this is going to be 0.5 minute, right? The question is, what are the upper and the lower bounds of his average speed in kilometers per hour? So give your answer to three significant figure, okay, right? So here, this is your given formula, and the side note, speed equals distance over time. So, but first, we are going to find the lower and the upper bound of the distance and time, right? So distance over here, okay, and time will be over here, and I will use some sort of like table to determine the lower and upper bound. Okay, let's start with the distance first. Okay, for the distance, the lower bound will be 14.2 minus your error 0.05. You will get 14.15 kilometer. And for your upper bound of the distance, it will be 14.2 plus 0.05, so you will have 14.25 kilometer. So those are the bounds for the distance. And for the time, it will be 46 minus 0.5, so you will have 45.5 minute. And for the upper bound of the time, it will be 46.5 minute. Okay, let's double check them first. Okay, make sure that your bounds are correct before you apply the formula for speed. Now, let's start with the speed, okay? Now, what are the upper and lower bound of his average speed in kilometers per hour? So here, let's begin by finding the upper bound of speed. Okay, the upper bound for speed, apply the above idea that you know just now, which is about the upper bound. The upper bound will be a upper bound for the first quantity over the lower bound of the second quantity. So let's start with the upper bound for what? So it will be the upper bound of distance, right? Divided with the lower bound of time. So why do I use this format? You will know later, okay? Now, let's start. Okay. The upper bound of speed is the upper bound of distance, which is 14.25 kilometer. That's the upper bound for distance, divided with the lower bound of time, which is 45.5 minutes. But here, your answer for the speed will be in kilometers per hour. So you have to convert the time to hour by dividing the 45.5 by 60. So this is already hour. So when you use a calculator, you will get 10.80625 kilometer, right? 625 kilometer per hour. So this one, you will round this off to 3 significant figure. So you will get 10.8 kilometer per hour to 3 significant figure. Right, next one. You are going to find the lower bound of speed. Lower bound of speed over here will be the lower bound of distance, right? And then divided by the upper bound of time. So this is applying the idea that dividing by a bigger number will get you a smaller number, right? So lower bound of distance is 14.15 kilometer divided with what's the upper bound of time? This is it is 46.5 over 60 hour. Okay, minute converted into hour. Now for your answer, it will be exactly, or using a calculator will not as exact. So 18.25806, and your answer will be given in 3 significant figures. So it will be 18.3 kilometer per hour. Right, so that's for the first example. Now for the next example from past year paper 2006, Maths D, paper 1. Right, so let's start. In a race, an athlete runs 1,600 meter at an average speed of 6 meter per second. So the distance is given correct to the nearest 100 meter. So here you will straight away get the error, which is 50 meter. And the speed is given to correct to the nearest meter per second. So here 1 meter per second. So the error will be 0.5 meter per second. Always make it habit. And when you see this one, okay, this statement, always find the absolute error straight away, right? So A, complete the two statements in the answer space. So you have the inequalities for distance and speed. So here you will put your lower bound, and over right side you will put your upper bound for each unit. Okay, so here, so for distance, just fill this in. Your lower bound for the distance is 1,600 minus 50 meter, so you will get 1,550 meter, right? And for the upper bound for distance, it will be 1,600 plus 50 meters, so 1,650 meter, right? And for the lower bound and upper bound for speed, it is 6 plus or minus 0.5. So for speed, 6 minus 0.5, it will give you 5.5 meter per second. And for the speed of the upper bound for speed, 6.5 meter per second. Okay, you completed A already. Usually for O-level exam, the part A will help you to answer part B. So here, let's have a look at part B. Calculate the greatest possible time the race could have taken. So here you are given the distance and speed. You know your upper bound and lower bound already. So you just have to apply this formula over here. Since speed equals distance over time, so exchange time with speed, you will have time equals distance over speed. So since here you are going to find the greatest possible time, it means that you are going to find the upper bound for time. So the upper bound for time will be here. So let's have a look. The first quantity is distance. Since you're going to find the upper bound for time, you start with the upper bound for distance. Okay, I'll just put D over the lower bound for speed. I'll just put S for speed. So let's plug in the value. So the value that we'll get over here is the upper bound for distance is 1,650 meter, right? and then divide it with the lower bound for the speed is 5.5 meter per second. And if you notice just now, this is a paper one base, so when you try to do this, you have to use a manual calculation of division. So 16,500 divided by 55. So this will yield you 300. Okay, so here what's the unit for time? Since you are using meter per second speed, so your time will be in seconds, right? So that's it for the topic of multiplying and dividing measurements. I hope that it's easy to understand. So with that, thank you very much and see you again.